Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera kepada semua pelajar. Today we're going to continue our final topic on water transportations. For today's lesson, we're going to continue others requirement design for Fender system. Fender system ni dia macam stopper untuk vessel berlabuh. Ferry Terminal. So today we're going to cover for the Fender design and the criteria. General consideration Ferry Terminal. Ferry Terminal are reserved for smaller number of ships and regular service as opposed container roll on roll out terminal which serve different ships in more or less regular basis. However, cargo is less informed, usually includes vehicle like cars, buses, trucks and trailers, trains, walk on, walk off, hop in, hop out. Ferry terminal typically link fairly rapid road and rail traffic by floating bridges. System carry speed around 15 to 20 knots. Tak laju sangat ferry kan. In recent years, growing interest has been experienced high-speed ferries as transport passengers, cars and truck, but not for rail car. Jadi adalah kan pertama sikit sebab mungkin keperluan untuk mengejar masa ke kan untuk lebih pantas. Such ferry often catamarans and usually form aluminium to reduce the weight. Sebab size ferry ni besar, jadi kalau makin besar makin berat, jadi dia guna different material kan. Cruising speed between 32 to 40 knots. Ni ada perubahan dari segi kelajuan terkini. Such speed generate weak wave. So kesan dia tu ada bila makin laju speed, wave ataupun kesan daripada riak ombak air daripada ferry tu pun ada efek which may cause physical damage to ship and structures in vicinity if proper remedial measure not taken. Ferry operation may be enhanced facilitating approach, berthing, and loading, unloading, as well as introducing a new type of high-speed ferry such as catamarans, hovercraft, and hydrofoil. So this is a different kind or different type of the vessel. The design of flowing elements in ferry terminal of decisive importance, like first marshalling yard, ni kapal pembawa ataupun kapal peronda. Passenger facilities, ferry berth facilities. Today we're going to cover this design more. Fender system, ramps, squall protections. Marshalling yards, it is essential to prepare the layout of the land area in such a way different traffic categories are kept separate. This to help speed up operations, reduce bottleneck and avoid accident. Sebab ni penting kan, dia nak mengawal keadaan trafik ataupun kapal-kapal masuk ke kawasan pelabuhan. The departing traffic should never interfere with arriving traffics. Lane for waiting vehicle and without reservation should be separated. Reservation system will increase the required number of the lanes for waiting vehicles, but reduce the total required length of the lane because vehicle reservations spend less time waiting. Rough idea. Size of marshalling area to be may be obtained based on assumption waiting time during peak traffic of more 2 or 3 hours would be not acceptable. Number and length of the lane are determined from traffic forecast and arrivals distributions. Combine the capacity of the ferries. This means measuring area of the 2 or 3 ferries load departure frequency about once per hours. So dia bergantung pada situasi dan kegerapan juga. Measuring punya kapal ni. Okay, next factor passenger facilities. Okay, the required facilities of passenger are mainly shelter for use while waiting departures. Ialah keperluan kan, dari segi keselesaan dan sebagainya lah. In addition, facility for sale of refreshment and convenience shopping as well restroom should be provided. Sebagai tambahan kan. Tunggu saja tak buat apa, boring juga At least adalah tempat yang kita boleh rehat, nak perlukan makan ke sebagainya lah Total area requirement should be not less than 1 meter square per passengers. So ni dia limit sebab dia tak ada overnight punya preparation untuk cabin. So dia limitkanlah space dia tu. Kalau dia besar kan lagi besar dia punya size. Okay, for the safety reason, special gangways for passenger with or without passenger should be provided. Okay, ferry berth facilities, Fender systems. Okay, Fender system consists of fenders, which is a bumper typically manufactured out of rubber, foam, elastomer, or plastic. Ni material untuk jadikan fenders ni. Dia macam stopper lah. Stopper pada pelabuhan. Bila kapal rapat, dia effect pada fender ni lah. Fender absorb kinetic energy of ferry berthing against a jetty or quay wall. These are used to prevent damage to ferry and berthing structures. Sebab impact dia kuat sebenarnya, berat dia punya. Yelah, kapal tu pun berat, dalam air lagi. So dia ada dia punya energy punya transfer kinetic. Okay, Fender system with smooth frontal panel is required to allow rapid berthing. Okay, ni Fender Dan ni dia punya structure dia lah, sistem Fender kan. Dia bila kapal berlabuh ni, dekat dia punya pelabuhan ataupun tempat yang ni lah, yang dia punya berthing ni kan, macam tempat parking lah So kapal ni akan ditahan oleh structure ataupun fender ni lah Okay, the system shall be designed to absorb the impact energy from the berthing ferries with reasonable low impact force on the both ship and quay. Jadi dia tak nak lah benda tu rigid sangat kan dia bergegar nanti kan boleh jadi kerosakan pada vessel dan juga pada ferry, pada bahagian darat pun ada efek juga kalau dia rigid sangat Continuous fendering system with smooth front panel was normally used. The berth range from closed type equal length of fender on each other the ferries. The open type fender along one side only. Such arrangement necessary due to limitation movement of the ferry. Okay, recent development include to introduction shelter propeller able to rotate 360 around the vertical shaft. Ini teknologi kan, dia nak mengurangkan kesan tu kan. Jadi propeller tu sendiri kan dia ada fungsi dan peranan lah untuk memperlahankan dia punya kelajuan dan juga masa dia nak arriving tu kan. Ferry berth facilities which is next ramps, ada ramp juga bukan jalan raya saja ada ramp area pelabuhan tu pun dia ada juga elemen ramp tu Okay, ferry ramp is a movable ramp installed at the inner end of the ferry berth. Ini jenis removable maksudnya dia boleh pasang dan boleh keluarkan Ferry usually not equipped with ramps, and the outer of the shore ramp is connected directly to bow or stern of the ferry. So dia ni sebahagiannya memang dia tak permanent benda ni. Dia boleh dipasangkan dan juga boleh Di standby macam tu lah Okay, RAM designed to sustain vehicle load and to be able to transfer vehicle safely when extreme water level occur. The length of the ramps may be determined based on high and low water statistic. Dia punya water level lah The maximum allowable thickness of the ramps, the specification vehicle to transported. Jadi dia macam gangway jugalah, tapi ni yang besar lagi lah Okay, kalau lihat ke posisi apa ni sebuah ferry ataupun small boat kan, ataupun sistem pada boat tu sendiri ataupun vessel tu sendiri. So area tepi ni dia akan ada ramp untuk keluar masuk Okay, berth facility, scour protections. Okay, proper scour protections against propeller erosion from the water jet of ferries is important component of ferry terminals. Scour protection may consist of layer of armor stones on the seabed. Ini bahagian dia limbungan bahagian limbungan. A continuous layer smaller stones encased in the steel wire cage gabion. Ini bentuk gabion lah. Ini batuan yang tak ada gabion or continuous concrete pavement. So facilities or structure ni boleh digunakan pakai untuk scour protection So macam ni kan layout dia kan. Okay, ni untuk concrete yang pakai block Okay, next Fender Design ni yang topik main kita nak belajar ni Fender should be provide necessary interface between the berthing ship and berth structure. Okay, a properly designed fender system must be therefore be able to gently stop the moving of berthing ship and absorb the berthing energy without damaging ship, the berthing structure or the fenders. Itu yang penting Dia punya elemen ataupun requirement design fendering system ni. When the ship berth and safely moored, the fender system should be able and strong enough to protect the ship and berth structure from the force and motion caused by wind, wave, currents, tidal change, load and unload cargo. Sebab dia behavior dekat perairan ni ataupun kawasan yang berth tu sebab dia dalam air. Jadi mungkin dia punya behavior vessel tu, hentaman dia, ayunan dia kan, bukan saja daripada berat vessel tapi surrounding dia tu ombak, gelora kan, naik turun pasang air. Okay, factor having impact on the thrust of fenders, the size of the ship, navigation method, the location, tidal difference, water depth. Ini ada kriteria yang perlu dipertimbangkan untuk design atau pemilihan fender. Okay, when choosing fender system, the impact energy must be absorbed, which is EF. Ini impact energy absorb. Okay, the force, which is P, the berth must resist to have be keep in mind. So dia akan tengok ratio between force and impact energy absorbed. Okay, this means the choosing fender factor, comparing or ratio between force and energy impact absorbed to meet both requirements. Okay, fender can be divided into two groups. The first one for high impact, which is surface protecting fender that transmit high impact or reaction force, the berth structure for each 1 kilonewton of energy absorbed. Okay, this consider high portion or ratio. Okay, the second group, energy absorbing fender, transmit low impact or react force to berth for each 1 kilonewton of energy absorbed. Okay, this one consider fender factor is low. So dua kategori ni lah. Okay, these are the two type of fender. Fender fixed. Fender fixed are mounted to the berth structure. This include buckling fender, which is cell and V type fender, and no buckling fender, which is cylindrical fender. Fender ni pun banyak dia punya bentuk dia, dia punya geometric design tu sendiri. Ini the fender, maksudnya dipasang lekat pada berth area tu lah, berth structure tu. Okay, second one, floating fender. Ada juga yang terapung dekat air tu. Dia ada impact juga untuk dia absorb. Tapi dia tak terlekat directly pada structure kan. Okay, fender between the ship and berth structure. This can be either pneumatic fender or form fill fender. Jadi dia macam berongga ataupun jelas sebab dia nak terapung kan. Okay, this typical shape of the fender. So dia ada yang jenis macam ni. Ini yang lekat pada structure ni. Dia ada ratio dia, berapa energy absorption dan force yang dikenakan pada fender tu sendiri. So macam-macam bentuk. Ini V-shape. Yang ni yang rectangle sikit lah. Ada yang silinder. Ada yang silinder. Ni yang silinder. Ni form. Ini floating. Floating. Ini masih lagi structure yang lekat. So ni yang floating. Pneumatic and form. Okay, this the fender factor, different rubber fender. So dia ada dia punya kesan impact dia pada high to low to be compared. Okay, spacing of fender varies depend on type of the structure, the requirement to met by berth and type of ship. Generally, to ensure all the ship can be supported at the berth, the fender spacing will be, okay, the first one consider berat boat sehingga 20,000 dead weight tonnage. So this one can be spacing between 5 to 10% of the length ship. So dia consider kalau panjang ship ni 100 meter, kalau nak taruh dia punya spacing fender ni 10 meter ataupun 5 meter. Dia ikut ratio ni. Kalau ship yang besar lagi, okay, up to 25 to 50% portion of the length ship. So this one the largest ship with tugboat. Ni boat penunda ni kan. Boat penunda ni macam kecil tapi dia kuat, dia strong, dia nak tarik boat yang besar-besar atau ferry yang besar-besar. Okay, theoretical kinematic method estimating berthing energy and impact force. Basically dia akan refer formula ni lah. Formula kinematic energy, kinetic dan M ni mass mass daripada kapal dan juga hydro ataupun dia punya ni lah, dia punya sesaran air tu sendiri. Okay, MD mass of design ship or displacement ship. MH hydrodynamic at the mass moving the ship. Maksudnya ini badan kapal lah. Ini yang beban daripada pergerakan air. Kapal ni kan dia bergerak dia sekali dengan air kan. Dia punya effect, dia berat dia. Dia punya apa istilah dia kan. Saya lupa kan nama spesifik dia punya tu Tapi beban daripada air tu sendiri Sebab air ni bila bergerak dia akan menyerapkan tenaga juga Okay, V ni speed lah velocity is normal speed. Okay, when the ship moving, it is necessary to consider movement of the volume water at the ship. When the ship stop, additional mass of water continue move, press again the berth. This additional mass of water as hydrodynamic mass. Dia punya ingat tak kalau kita belajar dalam kursus apa dalam kursus hidrolik dalam kursus hidrolik ada teorem apa dia panggil dia air itu menyesarkan ataupun air itu displacement pada berat. Jadi air yang tersesar tu dia consider satu beban juga formula apa saya lupa, tak ingat hidrolik lama Okay, for the berth structure design, the displacement of fully loaded ship should be used. Okay, of the kinetic energy of the ship, the fender system has been absorbed, which is EF. Ni F ni kira absorb, absorb. Bukan force lagi, absorb. Nak menahan maksudnya. So dia ada C, coefficient, berthing coefficient. Kemudian 1.5. Yang formula basic ni lah, yang ni. Cuma yang ni dia tukar untuk yang first ni EF. Okay, V ni speed. Cuma yang C ni, dia complicated sikit. So there is many factor to consider coefficient ni. So dalam C tu segi dia ada apa? CH, CE, CC, CS. CH hydrodynamic mass factor. Okay, CE eccentricity effect. CC water cushion. CS softening effect. So dia ada pecahan lagi. Dan dalam C ni pun ada pecahan lagi. Panjang tu formula dia. So CH ni dia dipengaruhi oleh displacement of the ship. Displacement dia panggil. Displacement pergerakan. Okay, MS ni tak adalah hydrodynamic. Okay, CHR just factor lah kan. Reaction factor due to ship movement at angle it longitudinal axis. Okay, formula ni lah. Dia akan guna pakai untuk determine CH. Untuk dimasukkan dalam formula ni. Kemudian barulah semua ni boleh calculate dapat C. Dia macam tu. In principle, reduction CHR, hydrodynamic mass of the ship normally moving normal to the berth line open water will be 1.0. Itu keadaan pertama. But for ship moving along the longitudinal axis, open water can be assumed about 0.1. Dia terbalik pula. Dua keadaan ni lah. Okay, over a year, CH base suggested action by figure this table 4.3. So dia dah ada pendekatan untuk mempertengahkan pengiraan faktor untuk ni lah CH ni. So yang latest dia akan gunakan yang terkini lah kan. Ini dua-dua dia renew kan, dia renew. Okay, the formula West Coast, Costa and Ueda are most commonly used for this nowadays. So generally that recommended with depth water depth 1.5 times draft of the ship or more. So CH consider 1.5. With water depth 1.1 times draft to ship which is 1.8. So ni tengoklah dia punya kelas dia macam mana kedalaman air nak dibandingkan dengan ship tu. Okay, next factor, eccentricity effect. The eccentricity effect factor is the due to consideration of energy dissipations that arise from the rotational motion after berthing around contact to the either bow or stern. Ni dia punya itulah. Bukan nak kegegaran Dia ada efek lah kalau goyangan. Dia ada centric dia punya efek tu. Okay, eccentricity effect given by this formula. So ni just masuk value dia. Okay, I ni ship radius inertial between 0.2 L. So L ni panjang Ini sebab panjang or 0.25 L. Okay, R a distant point contact to center of the mesh. Okay, dia punya sudut dia. Kita boleh refer kat figure ni. Untuk figure ni refer sudut dan ni nisbah untuk kita lihat dia punya eccentricity effect. To compare dia punya sudut ni, angle dan R over L. So R ni lah distant point. So kat sini kita akan lihat dia punya carta dia untuk dapatkan CE ni. So basically CE ni pakai formula ni lah. Ataupun dia punya carta ni kita boleh dapat direct juga. Okay, the berthing angle alpha using 1.1 to 5 degree. If the ship is berthing with boat assistant, 10 to 15 degree if the boat berthing without tugboat assistant. Okay, next factor, water cushion effect, CC. Okay, water cushion effect range between 0.8 to 1.0 at solid and open berthing respectively. If the bottom is steeply sloping under the berth, the resistance from the water will increase when the ship comes near to the berth. Okay, this is true at the solid berth, such as steel ship pile structures, where the water has been squeezed aside before the ship can touch the berth. Effect water cushion kan. Uh, kan dalam tu kan dia ada kesan hidrolik ni effect kan. Jadi setiap kali pergerakan tu dia macam lateral punya force juga kan. Okay, for the open berth structure where is usually easy way out for the water, this cushion effect will be very small. Ini yang jadi open structure. Ada yang macam dia punya berth tu kan, dia ada ruang macam apa nak panggil macam slot lah kan. Kata slot pun benda tu besar tak boleh kita slot macam parking punya space tu tapi ada yang open ada yang memang ada parking punya structure okay. Softening effect, which is SC. The softening effect is determined by ratio between elasticity or flexibility of the ship hull, badan kapal tu and the fender system or the berth structures. For the small ship, CS generally taken 0 and 1.0, tak defect sangat kan sebab dia kapal kecil For the hard fender and larger ship, CH may range between 0.9 to 1. So ada effect sikit kalau dia besar sangat ada effect juga sikit. So according to the Code of Practice for Maritime Structure, so ni BS ni British punya standard Hard fender system can be considered as the one where deflection fender under impact from the ship less than 0.5 meter. Okay, approach speed which is V, speed atau velocity. The approaching berthing velocity is the most influential variable in the calculation for berthing energy. It is defined as ship speed at initial berthing contact measure perpendicular of the berth line. Normally, smaller ship, higher velocity when hitting the berth structure to do larger structure than to larger ship. So figure point 4.8 shows velocity of small to medium ship berthing without tugboat assistance and under various weather and maneuver condition. So ni jenis velocity punya effect So ni dia punya berat ataupun beban ship displacement sehingga 20,000 yang rendah 1,000. Tengok saya kapal kan berapa besar dan dia ada juga kaedah-kaedah ataupun keadaan olah gerak boat tu sendiri okey ke, moderate ke, susah ke, keadaan faktor cuaca pun ada juga kuat ke angin, tahan ke, gelora ke. Okay, table 1.4 ship velocity during berthing with tugboat assistant. Ini ada bantuan daripada tugboat lah boat penunda kan. So dan dia ada effect juga consider yang biasa, moderate or unfavorable conditions. So ni pun ada juga dari segi size beban kapal sehingga 100,000 tan buat betul Okay, recommended mean berthing velocity with tugboat assistant is given in 4.9. Okay, based on the ship displacement and the following navigation conditions. So ni pada kategori kan ni. Kategori A, B, C, D, E Okay, ni yang good berthing condition ada shelter, difficult berthing condition ada shelter, kemudian yang ni easy berthing condition exposed. Ini good berthing condition exposed, difficult berthing. Dia ada kategori ni, kategori shelter dan exposed, kategori difficult and easy or good So ni semua ada refer line ni lah untuk refer dia punya tu lah velocity Okay, empirical method estimating maximum impact energy EF ni So daripada graf ni dia ada juga dia menggunakan empirical formula. Guna formula ni. So 10 MD ni berat kapal efek pada kapal direct ni. Okay, a factor 0.5 may apply in case where the impact would either shed between two fender or accompanied retraction of the speed. Okay, statistical method of the estimating impact energy. The statistical method design method is based on actual measurement of the impact energy absorbed by the fender during berthing. As the energy were actual value observed, it automatically include the effect berthing velocity, hydrodynamics, mass and eccentricity, etc. The Rotterdam curve in the figure 4.10 show the measurement conducted in the Rotterdam. Rotterdam ni kat mana Rotterdam ni dekat Netherlands Rasa kat Netherlands Rotterdam. Okay, while the two other curves, those recommended by British Code of Practice and the Norwegian Standard for the structures. So ada 3 rujukan yang digunakan. Rotterdam, British and Norwegian. So tengoklah yang mana kita nak refer yang standard requirement dia. Mungkin ada yang gunakan Rotterdam, ada yang gunakan Norwegian, ada yang gunakan British. Okay, next lihat exercise macam mana dia design fendering ni. Okay, exercise 4.5. A fendering system to be designed for an open pier structure for the ship of 6,000 ton displacement at 5% confidence levels. Ini steep punya judgement. The ship length, width and depth are approximately 105. Ini panjang. Width 14.2 and depth ketinggian boat 6.4 meter respectively. The following assumption dia punya angle dia 60 degree. Okay, hydrodynamic mass coefficient 70% because the ship does not move perpendicular to its longitudinal axis. Okay, others CC equal to 0.1, softening effect CS 0.95, the distance from gravity vessel to point contact is 0.3 L. So ni ratio tadi dia punya effect tadi tu. Okay, dia ambil 0.3 Okay, safety factor abdominal impact 1.3. Velocity ni dia bagi terus tak payah nak determine dia bagi direct je, tak payah duduk graf ini pun tak payah duduk graf, dia bagi terus okay, 0.25 meter per second okay, the fendering system shall be chosen from the following table. Must be able withstand of horizontal force 900 kN/meter. So beban yang akan ditanggung oleh fendering ni atau fender ni boleh menanggung sehingga 900 kN. So dia akan lihatlah dia punya jenis rubber fender yang mana akan digunakan yang boleh menampung dia punya ni lah horizontal force seberat 900 kN. Ini bukan dia punya force lagi tak ini lain reaction loading sebagainya tak. Kita akan lihat dia punya nisbah ni jelas kali ni. Force over dia punya impact absorb ni Tapi kita kena design dulu Okay, first kita calculate dia punya hydrodynamic mass. Okay, which is formula dia MH quarter pi ni rho ketumpatan air. Tapi ketumpatan air laut D ni dia punya depth L ni panjang. So kalau lihat kat sini rho ni bukan 1 bukan 1000 tapi pasal digunakan kilonewton kan. So ditukar. Dia punya ketumpatan air laut ni kalau kita lihat dia punya value dia 1023 3 kilogram per meter padu, ataupun ada yang rujuk 1029 kilogram per meter padu. Jadi ini adalah density air laut. Ni, rho ni kan density, ketepatan. Jadi bukan satu. Air tawar 1000. Air laut dia berat. Pasal dia salty. Dia ada saltiness. Jadi dia menambahkan berat. Okay, kita dapat dia punya hydrodynamic mass 3,378 ton. Okay, hydrodynamic mass factor which is CH. Okay, derive dari formula ni. So kita dapat dia punya factor dia 1.39. Okay, CHR ni dapat ni 0.7 ni. So dalam soalan ni dia kata okay, the hydrodynamic mass coefficient is 70%. Jadi kita consider dia 0.7. Okay, settle dapat yang CH. Next, CE, eccentric effects. So tadi kita dapat dah R over L 0.3, sudut pun dibagi. Okay, 0.3 pergi kat sudut punya curve ni 60 degree. So kita dapat eccentric value dia, CE dia, eccentricity effect which is 0.48. Dapat dah dapat CH, dapat CE. So kita apply kat sini lah formula berthing coefficient yang banyak-banyak C kan. Kita tadi dapat CH 1.39, CE 0.48, yang ni kita kira 1, CH 0.95, ni semua dibagi tadi. Okay, total coefficient untuk berthing is 0.63. Okay, energy to absorb Fender which is EF. So ini kita pakai formula yang kinetic tadi. Okay, C equal to setengah 0.5. MD dia punya sheet displacement lah. V velocity velocity pun dia bagi tadi. Velocity dia bagi. Okay, ni 0.25. Okay, berat sheet tu 6,000 ton. Okay, just apply dalam formula ni. So now kita dapat energy to be absorbed by Fender which is 118 kilonewton meter. So ni energy absorption dia. Okay, therefore first we calculate force. Okay, force yang perlu ditanggung ataupun force yang akan dikenakan pada Fender tu 900 km. Kemudian kita consider safety factor sikit 0.3. Okay, the horizontal force now to be 700 kN. Okay, now kita akan buat comparison. Kita akan nisbah P over EF. Okay, P over EF 700 divided by 118. Now we have factor for Fender 5.9 km per kilometer meter. So di sebelah ni lah kita akan lihat pada table type of Fender tadi. Okay, from the table, Fender 1 and 2 suitable because the factor for the Fender between 3.3 to 5.75. So meet the requirement. Jadi kalau kita lihat kat table tadi, saya tunjukkan mula dari masa exercise yang tadi tu. Okay, kita tengok ratio ni. Dari calculation kita, we obtain that the range 5.9. Okay, so inilah antara yang kita boleh consider untuk jadikan dia sebagai pilihan rubber fender material yang kita boleh gunakan. So dia boleh design secara pneumatic ataupun cord strip Cork street ni kira line lah kan. So ini mungkin yang terapung lah kan, jenis terapung. Sebab dia boleh consider untuk range ni lah. Boleh juga nak ambil yang ni tapi takut oversize pula takut cost pula Mungkin boleh lah kalau nak kasi yang ni tapi sebenarnya dia macam oversize lah. Sebab beban dia ni sampai 700 je kan. So consider sini lah kan. Dia bukan tak boleh lebih. Lebih boleh tapi kita oversize kita punya design lah, itu je. So cost structure ni kalau boleh kita design dia mengikut requirement dan juga kesesuaian Jangan kita nak oversize pula Jadi kadang-kadang melebihi cost Okay, I think that's all for design, especially Fender system for vessel at seaport area, at the berth area. Okay, that's all for cover lesson on this final topic water stabilization.